Hi, Mr. Crane here again for our fourth meeting for the week. So today we're going to pick right up where we left off. We're on questions, and I'll probably have to do a couple of different sessions for questions. So let's jump right into it. All right. So if we scroll down here below the first diagram right here, and we go to this diagram, so you can answer the first two questions kind of easy. It says, after constructing a model of your solar system, what is your impression of our solar system? So what do you think? I'm trying to put something in the middle of that football field from one goalpost to the other goalpost. Even at that scale, what do you think about the size of our football field? I'm sorry, the size of our solar system. So you should have some opinion there. Describe some advantages and disadvantages of our model. So I can tell you the one big advantage is we can see it. So if you went outside tonight and tried to see our total solar system and each planet, it's so big and so vast and they're so far away that you couldn't see it. So an advantage of ours is we can see it. We can see how far they are relative to each other. And a disadvantage would be that we had to use two scales to do it. I can put my planets out there on one scale on our football field, and you can see how far apart they are. But if I didn't change the scale, I couldn't see them. They're so tiny. And on our scale, they're so small. Describe Alpha Centauri is our closest star at 274,332 AUs. One AU is 150 million kilometers. Where would you put it on our football field? So 274,332. Let's put that down. 274,332. All right. That's Alpha Centauri. So didn't they say that was that many AUs? Yes, that many AUs. So that's AUs. Now, one AU is equal to the distance from the sun to Earth, 150 million kilometers. All right. So how would I figure up how many kilometers that is? That's easy. One AU is this much. I have 274,000 AUs. So I just have to multiply those together. When I multiply those together, that's going to give me however much that is. All right. So putting that on our football field, so I can multiply this together, 274 times 150 million times 100. That's the length of our football field. And I divide the whole thing by 4 billion. So that's supposed to be a 500 million. And it's supposed to be a 5 right there. Sorry. Billion, 500, 500 billion. All right. So I take 274 times 150 million. Make sure you have the right amount of zeros. Times 100 divided by 4,500,000,000. And I'm going to get some very large number. All right. So that's for C. Let's look at D. D says the Milky Way galaxy is roughly 100,000 light years. That's the distance light travels in a year times 100,000. So 100,000 light years. One light year is equal to is 150 million, like up there, 150 million. All right, that's kilometers. All right, 100,000 light years times 150 million kilometers. That gives me how many kilometers are in that 100,000 light years. And I want to put that on our football field. So I'm going to put that times 100. And I'm going to divide the whole thing by 4 billion, just like before. 400 billion, 500 million. Make sure you have your zeros correct. You miss some zeros, your numbers are off. All right. And that's going to give you how big it is on our football field. So if you want to know how many kilometers it is, that's just this part. It's just this part. If you want to put it on our football field, then you have to times 100 divided by 4,500,000,000. Okay? And I really, really don't like the way that looks right there. So I'm going to rewrite that right there. Sorry. It bothers me. 4,500,000,000. Not much better. It's all about how I move my mouse. Sorry. All right. Okay, so that's ABCD that we've answered. Let's move on to the next set of questions. We're only going to do 2 sets per video, so I'm going to do this one now. So how big is the sun on this model in units of centimeters? Well, you can't see it, but this is millimeters. It was like 30 point something once you figured that up. So it was like 30, I think 30.92. That may be a good guess. 30.92 millimeters. Okay. Well, I taught you that, and so other teachers should have taught you this too. So King Henry died by drinking chocolate milk, little lowercase. All right. So I'm going from the millimeter right here up to centimeters. So I'm going up. I'm going that way. All right. And I'm going up that way by 1 jump right there. Okay. So that means I move my decimal in the direction that I'm going. So I'm moving my decimal to the left 1 space. So I go over 1 space. So that should be 3.092 centimeters. That's provided that was the distance of the sun. I think it is. Okay. So that's A. This is A for that second set of questions. Let's go to B. B. How large is the sun's diameter compared with Earth's? How much larger would it be on compared? How much? Okay, so let's look at this one. So we don't even need any numbers for this one. So how much larger is the sun compared to Earth, and how much larger is the Earth compared to the moon? Well, let's do the moon part first. So the moon right there is 3,475. What do I need to multiply 3 times to get to 12? So 3 times what is 12? That's 4. 4. So it's 4 times. The Earth is 4 times larger, or the moon is 4 times smaller than the other. Okay? So that should be that. Now let's look at this one. Earth to the sun. What do I need to multiply to get to the sun? So 12,800. Let's go to that. 12,800. This is B. 12,800. This is Earth. All right. And then the sun is like 3 million. I don't remember. 3 million. No, it's 1,391,000. 1,391,000. 1,391,980 kilometers. All right. So what I got to do to multiply this to get to here? So I'm going from here to here. So if I put a 0 on there, 1, 2, 8, 0, 0, 0. Put my commas in. So if I multiply it 10 times greater, that gives me this number here. That's still not that big. It's still not that big. So this is much bigger still. If I go another 10, 10 times 10 is 100, right? Now I go 1, 2, 8, 0, 0, 0, 0. Put 3 there and 1 there. Now I'm getting closer. So 1,280,000 to 1,391,000. So I jumped it up by 10. So that's 10 times right there. That's 100 times right there. Going up another 100 or to 1,000 times, we put a 0 right there, and it's too big. So you need to figure out how many more times greater is this than this. So you go 101 times, 102 times, 103 times until you finally figure out a number. You're going to find that number is going to be very close to somewhere in that 110 mark, but it's not 110. It's really close to that. So good luck with that one. All right. Next question is C, the smallest object what the human eye can see without magnification is 0.1 millimeters. Given the information, which planet would be visible to the human eye? Would you be able to see the sun on this? So the answer, if would you be able to see the sun, is yes. So if we looked at our chart, up here, you guys should have these numbers right here. So the only way, let's take this one for instance. If I move this over 3 times, 1, 2, 3, that's going to get me 0.108. So I can see sorry, I was looking at something. So 0.0000108, 0.00108, 0.000108. I'll move that over 3 spaces. 1, 2, 3. That's going to get me 0.108. And this is for Earth. I think that's Earth. Is that Earth or Mercury? Mercury. So can I see Mercury? It's bigger than 0.1, so that would be a check mark. So what planets do you think you couldn't see? Try to figure that out. There's 2 of them that you can't see if we put Pluto in here. All right. What is your impression of how the size of the planets are in relationship to in the sun compared to the size of our solar system? So what is your impression of how the size of the planets and the sun compare with the size of the solar system? So the size of our solar system compares. So what do you think about that? You have this huge space right here. What do you think about that? You put those planets out there. Remember that one of the things that I had told you was if this were the sun and this were the Earth, that distance, 150 million kilometers, you could literally put Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, all inside of this space of that distance. So now they're spread all out. They're spread way out here, right? So, but that distance right there, that 150 million kilometers, is enough space to put every one of our planets touching from side to side and still have little room for little Pluto in there. So that's mind blowing. All right, that's the first half part of this for the first section. Hope that was helpful. And I'll see you on the next video.